Okay, we're going to look again at factoring some trinomials. Most of this today will be review, but there'll be two cases that are a little bit special. So again, my first step is to look for a GCF. I recognize that there's a 1 here, so that's going to make it there no GCF. So I'm going to have to make it 4 terms. So I do A times C, sorry about that, in the top. So 9 times negative 8 is negative 72. B goes in the bottom, so that's a 1. So my guess is that most of you with negative 72 are going to want to use your calculator. So you do y equals negative 72 divided by x. Second graph to look at that table. So you're looking for something that adds up to 1. And so I think you should see negative 8 and positive 9, or the other way around. Either way is fine. So negative 8 times 9 is negative 72. Negative 8 plus 9 is 1. So I'm going to come back, and I cannot take the shortcut here because A is 9. A is not 1. So I'm going to have to write it out the long way. So first and last. And I'm going to break this 1n apart into negative 8n and 9n. I don't know why my screen's going crazy. Sorry about that. So I'm going to split it. So on the left side, my GCF is n, and I'm left with 9n minus 8. On the right side, my GCF is 1. Not real interesting. I'm left with 9n minus 8. So I'll do my outside, my inside a repeated piece. I did not have a GCF, so there doesn't have to be anything out front. So that makes that my final answer. Okay, I'm going to look at the second one. So I see a 50, a 135, and a 140. So I'm going to really hope that there's a GCF here. And so if you don't remember, you can use your calculator if you do math, number, and then choice 9. And you'll put in 50, 135. Enter, and then your answer, you'll do that again, math, number, 9, your answer, 140, and when you do all that, it spits out 5 as your GCF. So I'm going to take out a 5, so I'm left with 10v squared minus 27 minus 28. So my numbers are still big, but they're not nearly as big as they were. And because I'm forgetful, I'm going to call attention to that 5 because I'm going to need it. So I make my x, because it's 3 terms, AC be negative 280. B is negative 27. And so my guess is most of you are going to want to use your calculator for this one. So y equals negative, that's a negative. I don't know why my pen isn't working. I'm sorry. 280 divided by x, second graph. And I'm looking for something with a difference of negative 27. And I'm going to have to scroll for a moment until I find this little combination. 8 and negative 35. So that calculator is really helpful. It would be a shame to not take the time to use it. So I'll keep my first and last, but this negative 27 is going to split into 8v and negative 35v. And so now I can split this. And again, I could not use the shortcut here because even after my GCF, my A is still 10. So that's a sad day, but we can handle it. The GCF of 8 and 10 is 2. So we get 2v. And we're left with 5v plus 4. 35 and 28 actually have a 7, but because the 35 is negative, I have to take a negative. So 5v plus 4. So I have my outside pieces, my inside or my repeated piece, and I can't forget that I took out a 5, so it has to come out front. And that right there is my final answer. Okay, if we look at this one, step 1, always the GCF. This does have a 2 in common, so that's good for us. So we're left with k squared plus 4k minus 45. I want to not forget about my 2. I also want to understand that there's actually a 1 here, which hopefully sends up a little red flag in my brain. If a equals 1, then I can use my shortcut. So once I do the x, I have my answer. So 1 times negative 45 is negative 45. I'm looking for a difference of 4. So you can either use your calculator or think about this. My choices are 1 and 45, 3 and 15, 5 and 9. And I'm looking to get 4. And that's not going to happen with 1 and 45. It's not going to happen with 3 and 15, but it can happen here. So negative 45, one of these has to be negative. Since I want a positive 4, it has to be the 5. So it's negative 5, positive 9. And now I'm really happy about this, because that allows me to use my shortcut. And so I can do k, sorry about that, negative 5 and k plus 9. So I just took my numbers straight from here and put them in my answer, but I don't need to forget that I did have a 2 that I took out, so I put that out front, and that's my answer. So understanding the shortcut, using the shortcut saves you a whole lot of time, and in some cases heartache. Okay, on this one, I notice right away that that's a 1, so I'm not going to have a GCF. I do, however, get really happy because my A is 1, and that means I'm going to get to use my shortcut. So A times C, 1 times negative 15 is negative 15. B is 2. So I'm looking for two numbers that add to give, or multiply to give me 15, that add to give me 2, negative 15, excuse me. So 1 and 15, 3 and 5. So it's not going to be 1 and 15, 3 and 5, but it's negative. So one of those has to be negative. Since we want a positive 2, it has to be the 3. And then I'm going to remember the A is 1, life is good. So we do A minus 3, A plus 5. I did not take out a GCF, so that right there is my answer. And I am finished. Okay, with this problem, because of this 1 at the end, we're not going to have a GCF. But A is not 1, so I can't use my shortcut. So either way, I'm going to have to make my X. So A times C, 4 times 1 is 4. And I'm looking for them to add up to negative 4. There's only 2 ways to get 4. 1 times 4 and 2 times 2. The only combination of that gives me a 4 is the 2's. But I need a negative 4. And so if I'm going to add 2 plus 2, that's going to give me positive. So they both have to be negative. And if we check that, negative 2 times negative 2 is positive 4. Negative 2 plus negative 2 is negative 4. So that's my answer. A is not 1. Sad day. Oh, I don't know what happened there. Sorry about that. A is not 1, so we're going to have to do it the long way. So we take our first and last, and I'm going to break this negative 4v into a negative 2v and a negative 2v. So I split this. This side has a GCF of 2v. So 2v, and I'm left with 2v minus 1. This side has a GCF of 1. But you need to be careful because we do lead with the negative, so we need to make it a negative 1. And we're left with 2v minus 1. So we do our outside pieces and our inside or repeated piece, and hopefully you notice something. This is a special case because these actually turn out to be exactly the same. So it is not incorrect to leave it written that way at all. However, if you are taking a multiple choice question, doing a multiple choice question, you will sometimes see it written like this. And just remember that that 2 means I have 2 of them. So remember, mathematicians are inherently lazy. We like to take shortcuts whenever we can. So this is not a new problem. It's just I don't want you to be confused by the multiple choice answer. Okay, with this one, right off, I see that my leading number is a 1. That is really nice for me because I know, because I paid attention, that if A is 1, I can take a shortcut. And you want to look for those shortcuts. So the top number, A times C, 1 times 16 is 16. B is 8. So I'm looking for 2 numbers that multiply to give me 16, that add to give me 8. That shouldn't be too difficult for us to think of, but we can list them. So if I look at my pairs, this is not going to add up to 8. So 2 and 8 aren't going to add up to 8, but 4 and 4 are really nice. So 4 times 4 is 16, 4 plus 4 is 8. So if I come down, my A is 1, life is good, so I can go straight to this. My answers were both 4. I did not have a GCF, so I can write it like that, or you might see it written like this, because it's just the same thing doubled. It has to be exactly the same thing for us to use this exponent of 2. This one looks a little different. It might freak you out at first, but it actually ends up being a pretty easy problem. So I'm going to show you 2 ways to do it. The first way is just your standard factoring method. So I look for a GCF. 16 and 25 have nothing in common. The problem here, though, is that there is no middle term. So I need to make this 4 terms still, which means I'm going to use my A, B, and C. But what happens is my A is 16, my C is 25, but there is no B. So if there's no B, that's a question mark. If there's no B, then in mathematics, when we represent nothing, we use a 0. So we're going to do A times C, negative 400. And I'm looking for something that adds up to 0 because there was no B here. Okay? So when I do this, 400, I would probably use my calculator. My guess is most of you will anyway. So I would type that in, y equals, I would do second graph. I'm looking for 2 things that essentially cancel each other out. And so you might have to scroll for a minute, but you'll eventually hit negative 20 and 20 and negative 20. So that means that I can use that. Now A is not 1, so sad, but it's true. So we have to come back and we're going to do 16n squared, negative 25. But instead of having nothing in the middle, we're now going to have a 20n and a negative 20n. So now it's 4 terms, so I can factor it. And so the GCF of the left side is 4n. So I would take out a 4n, and I'm left with 4n plus 5. And on the right side, my GCF is going to be a 5, but I lead with a negative, so I'm really careful to take out that 5. So I would get 4n plus 5. And so my final answer would be 4n minus 5, 4n plus 5. Now the temptation here would be to write this like we did this one with a squared. But if you look carefully, they're not exactly the same. One's plus, one's minus. So this is my final answer. We have to leave it as it is. But there's nothing more we can do to it. Now, that was a lot of work for this problem. So I want to show you another way. You are welcome to do everything like this using this method, okay? But I want you to come back up here and look at this with me. There's something special about the number 16 and the number 25. And it has to do with the square root. If I take the square root of 16, I get 4. If I take the square root of 25, I get 5. So they're both perfect squares. There's also subtraction here. So this is actually a special case, and it's called a difference, which means subtraction of squares, which means perfect squares. So it's a difference of squares. So if our problem meets that criteria, both terms are perfect squares, and it is a difference. So if it meets that format, and only if it meets that format, then I can kind of do something different. So with this format, I can take a shortcut. So I would check, they're both perfect squares, it's a difference, it's subtraction. So I would take the square root of, let me just rewrite the problem down here for us. So it was 16n squared minus 25. So I would take the square root of both sides, and I know that one factor is going to be addition, one factor is going to be subtraction. So the square root of 16 is 4. Square root of n squared is n. The square root of 25 is 5. And so my final answer is 4n plus 5, 4n minus 5, which is the same answer as that. It's just written in a different order. So much faster, but you have to be able to recognize it. Is it a perfect square, and is it subtraction? So this one, same type of deal. I'm going to go ahead and make that a 1. So it's only 2 terms, so I'm going to check and see if it's a difference of squares. It is a difference because it has subtraction. So I'm going to look at my numbers. Is 1 a perfect square? Yes, because the square root of 1 is 1. 9, square root of 9 is 3, so it's a difference, and it's squares. So that makes life really easy. So I know it's going to be 2 factors. One's addition, one's subtraction. So the square root of 1 is 1. Square root of x squared is x, so either 1x or just x. Square root of 9 is 3. And that's all there is to it. That's my answer. It's really easy, but it has to meet the criteria for a difference of squares. Okay, this problem, again, first step always, GCF. So if I look all the way across, I can take out a 3 here. So I'm going to want to do that, and I get n squared plus 4n plus 4. So now it's 3 terms. This is a 1. So this is A, B, C. So my A is 1. Life is good. That means I can take a shortcut. So I'm going to go ahead and make my x. So 1 times A times C. 1 times 4 is 4. B is 4. So we're looking for something that multiplies to give me 4 that adds to 4. So there's only 2 choices. Not 2 times 4. clearly that's not 4. 2 times 2. And so if I want it to add up to 4, I'm going to choose the 2's. Since A is 1, now that I've taken out my GCF, then I'm going to go ahead and write my answer as n plus 2, n plus 2. But I have that 3, so I don't want to forget it. And I know that sometimes I'm going to see this written this way because those are exactly the same. So don't forget about that. Don't let it confuse you if it's a multiple choice question. Okay, first step, every single time we factor, GCF. So I can take out a 3. So I get 3v squared minus 25. And I don't forget there's a 1 there. Now, 2 terms. So my brain is like sending up signals. Is it a difference of squares? It is a difference because it's subtraction. Is 1 a perfect square? Yes, because the square root of 1 is 1. 25? Yes, because the square root of 25. So it is a difference of squares. Life is good. So I know that 1 is going to be addition. 1 is going to be subtraction. The square root of 1 is 1. Square root of v squared is v. Square root of 25 is 5. Before I get too excited, I need to bring down that 3. And the temptation here is to rewrite it like we did this one. But remember, those are not exactly the same, so we have to stop there. I want you to do 11 through 34. Look for the GCF first. Look for the a equals 1 shortcut, and look for the difference of squares. You'll find that there's actually quite a few of those. Put it in the tray when you're done, and I'll see you soon.